I also want to point out that as I go through the presentation, everything is going to be using Postgres 9.5. So something worth keeping in mind, even though some of these formats have been around since 9.1, Hstore, for example. Also, a brief note on posterity. I know whenever I'm going to technical talks, sometimes it gets really frustrating when the slides go really quickly and you're trying to take a photo, and I hate that. So I have your back there. Don't worry about that. At the end, there's going to be a little QR code that you can just scan that'll take you to my GitHub with all of the links and code samples that I'm showing you. So you don't need to worry about frantically taking photos. So there are several different data formats in Postgres. And the four that I'm going to go over here are XML, Hstore, JSON, and JSON-B. And fun point, that B stands for better, since it is better. It is a better format. Coincidentally, the JSON-B format is also a binary object in the database. So whenever I go over JSON, I'm going to look at both of those together so you can get a comparison of how they work. They use the same operators, so that kind of makes logical sense. But I'm going to go over them in this order and take a look at the various differences mechanically when you're querying with them and how they feel whenever you're operating with that data, because they have many pros and cons. So again, whenever I was coming to it, there were many options available to me, and I didn't know that at the outset. So I wanted to go over some questions that you can ask yourself to get a good sense of where to start. There are many things that might inform your decision to choose a particular document data type. A really easy one would be, are you wrapping a foreign database? So a lot of y'all might be familiar with the foreign data wrapper feature that Postgres offers. For example, if I wanted to wrap Redis, that's a key value data store. Hstore is probably a good right off the bat choice there because that closely resembles the foreign data source. Similarly, if I have a Mongo database that I'm trying to wrap, you might want to use JSON-B with your schema because the BSON syntax that Mongo uses is really close to JSON anyway. So your data is very similar, and that makes it easy for you to make a schema decision. Not everybody's data is necessarily that straightforward, though. So some other questions that you might need to ask are, what does your data look like? You know, do you have a fairly nice normalized object model with some weird objects that have funky attributes? A good example that I like to talk about is if you're building a database for a car rental service, perhaps, or one of my old mentors built some software to manage real estate holdings, for example. And there are a lot of really little teeny variations in options for a real estate property, for example. And I mean, if you want to get really pedantic about normalizing your data, you could do that, but it would get very unwieldy quickly to have different tables and having join tables to connect all the small features that a given real estate property can have, like granite countertops or lawns, xeriscaping, all that. So if you have a richly nested data object that can contain all of that, that can make your life a lot easier while the bulk of the data can still stay in a nice normalized data schema. That could be a good option for you. Very important consideration, though. So the topic is Postgres's NoSQL superpowers, and they are pretty rad. You can do some pretty powerful things, very similar features to what you can do with NoSQL, but it's important to keep in mind that lock contention is still going to be a concern here. So for example, if I have a very write-heavy database and I'm like really overloading my JSON field with a ton of data that's getting heavy writes, that's going to really slow down performance because while that row is locked, I won't be able to make the subsequent writes. So this is worth considering. The NoSQL features that Postgres offers are really powerful, but with great power does come great responsibility. So making sure that we're using those complex data types wisely and breaking our data out into logical ways that won't trip you up later is worth considering. So yeah, write lock contention is still definitely a thing here. So those are some high-level questions to keep in mind. Maybe you're already thinking about the software that you yourself work on and how those questions relate to your software. So things to keep in mind as we talk about each type. So the first one I'm going to go over is XML, which I'm guessing not a lot of us work on too heavily anymore. I know that, hit mic, sorry. I know one of my first gigs, we were using a SOAP API that had an XML payload. We were processing financial data, and I used the ton out of XML. Maybe you don't see that as much anymore now that we're working with more RESTful APIs, but you never know. So this is a really helpful thing to know how to use, and personally, I find some of the querying abilities to be really powerful with XML. So first, I'm going to dig into how you'll create your schema. This is probably pretty straightforward for most of you. The nice thing is XML is available to you right out of the box. You don't need to create any extensions or install anything fancy. It's there. And once you get your table set up, you can insert some data. And there are a couple of ways you can do that. The way I'm demonstrating here is using our XML parse function. So this gives us the ability to hand an entire XML payload to the field. And then using this function, it'll parse it. And note here, I have to pass a parameter to tell the function what kind of data to expect. So here I'm telling it, I'm going to give you an entire XML document. Here it is. Do what you need with it. And there's the XML header here. So there's a link to this later, but what this XML document relatively looks like is a catalog of books, as if you were in a library. So we have a top-level key of a catalog, and for space, I've redacted the books. So you have child nodes that are books with metadata, and this would represent an entire XML document that this function knows how to parse on insert. And I have a little comment here that this is an entire XML document. So that's one way of inserting into XML. That can get, again, a little unwieldy because you have a giant, God blob of information, which is tricky if you're making frequent writes. So another strategy that you can use when using these rich data structures is putting your child nodes one row at a time. So for example, here, remembering we have a book catalog, what I'm doing here is I have a book here. So that's one child node from a catalog. And I'm inserting one book per row. And that gives us a little more flexibility as to when we need to make updates to those records. And also note that I don't have the XML parse function here because I'm not giving it an entire document. It doesn't need to parse that. It will enforce that this is valid XML. It'll throw an error if it's not valid XML because we have formatted this column to be an XML data type. But you can get a little more flexible because it's just the one node. And this is where the fun begins, right? So this is where the superpower stuff starts to come in. Because you've got a lot of rich data in here, and you don't necessarily need all of it at once. You can get really specific with which data you need to pull out of your blob. So here, I'm demonstrating the XPath function that gives you that ability. We're only pulling items out in the title key of that XML document from the XML samples table. So the XPath function takes the specific XPath you'd like to access and the column that you'd like to access it from. And I will demonstrate that here in just a moment. You can also get fancy, and here I'm using the same function. I'm using this XPath function, and I'm pulling it from the documents column. And these items come back as an array. So I need to use an index operator to pull the specific object out of that array. But I'm only pulling out items where the text equals Midnight Rain, one of the books in our catalog. So I'm going to show you that in action. There we go. The slide clicker is not as happy with YouTube embedding as Google Slides is. There we go. So I'm going to start out with an empty database, no tables. And here we are adding our database table. So here, I'm going to go over and copy some text that is just one database, or one book node. And you'll see here's our title, or that's the author, rather. Here's our title. And we're inserting into XML samples that book, just that one book. And we didn't use the XML parse function since, again, this is not a full XML document, so that function would be a little bit of overkill. We don't need that. The data type natively enforces that this is valid XML. However, we do want to experiment with using an entire document because that is one of the cool powers of Postgres. So I have a text file over here with the full document, and it is using that XML parse function. Now, the reason I have it in a separate text document and I'm inserting it using the psql-f flag is because this saves a ton of time escaping characters. You would need to escape those characters, and it's really tedious. So I have made a shortcut by using that -f flag. The nice thing is, because this is text under the hood, it is pretty printing, and you can see all of the records that I've added. So here's our full, well-formed XML document. And you may note here that that XML parse function has stripped out the XML header, because we don't need that. It's parsed the XML, it's verified that it's valid XML, and then it's entered our data into the database, and we're good. So here, we're going to take a look at this catalog. We have a catalog node, we have a child node of the book ID, and then we have the title. And so I'm querying all of the titles. I forgot to turn on auto display. Yeah, so here we are. We have a whole list of titles. I've dug into that XML and only pulled out the data that I need. And that's our list of titles. So we have 2 arrays. Now, here's where it gets a little more complicated and where XML doesn't, in my opinion, lend itself to frequent complex querying. It's nice. I would say XML is nice for asynchronous processing. But if you need to do a lot of reads and writes, this can get a little unwieldy. Like, for example, here I would need to use the index to pull the item out of the array. I would need to know that index number to know what to query for. And here I'm not turning anything up because I only have those 2 records. And none of the records that I need are at that index array. So what I'm going to do is go back and add some more nodes. And again, I'm using a different strategy here. Now I'm putting the child nodes, so each book is going to be 1 row in our database. So I'm adding that in now. Boom, data. So this is referring to the text that we just inserted. We have 1 book per row. So now whenever I go and query based on that exact XPath, I get 1 item in that array, and that is Midnight Rain. It matches that text, but I also have to use the index operator to pull that out of my query. So that's kind of unwieldy. Now, the other limitation, unfortunately, with XML is that you can't update things natively, which is kind of a pain. You'll see later that you can use a concatenation strategy to overwrite keys and values. But for XPath, this is not really something that you can do. So if you were going to be using XPath, that might be handier if you're working with an API that does return an XML payload, and you might want to process that asynchronously. So you get your API response, you write it to your database, and then you have a worker queue process that information later. So that's a good use case for XML, but maybe not if you have to do a lot of heavy reads, writes, or if you need to manually manipulate that data. It's kind of a pain.
Are there any plans in the future version that they are going to work on the updates?
That's a good question. I'm not sure off the top of my head since I don't contribute to the Postgres internals, but I can definitely ask some of the team. Thank you. So regarding reads and writes, Hstore definitely has that capability. I've used this one a fair bit. And this one's very nice and elegant because it is a straight up key value data type. It's not quite as complicated. And it's text under the hood. Is my clicker working? Come on, clicker. Yeah, there we go. Cool. So this has been available since 9.1. This feature's been around for a while, which is very nice. A lot of the legacy code bases I've worked on have been using this for a while, and it's useful. So you might see it a lot as you approach new code bases. This one is a contrib module, so you do have to create the extension before you can really get to work on this one. But one of the exciting things about this data type is that it does support indexing. So you can create your row and then have an index on the key within the field, which is pretty cool. So making our schema is pretty straightforward again, except you need to remember to create your extension first, or it won't work. So here I've pulled some sample data from my staging environment. This just represents a cluster of Postgres databases with resource names that are, a little haiku naming convention. So Swimming Swiftly is the name of the database in the cluster. And this database is a 30 megabyte database, and when it was created. So you'll see that this is just string. It's a straight up key value hash as a string. It's text under the hood, but making it an Hstore gives you those extra indexing superpowers, really. So that's how you add your data in there. And now, whenever you're accessing that data, it's, again, important to remember that this is just text. So whenever you're attempting to make comparisons on the value of that key, you do need an explicit typecast. So here, for example, I'm looking for databases above a certain size. And if I'm making a comparison to an integer, I do need to make sure I'm explicitly typecasting the return result as an integer, or it will not be happy. More fun things that you can do with Hstore. You can get specific columns, or rather, you can get specific keys. So imagine that you have a huge Hstore blob, and it's got, 20 keys in it. That's really unwieldy, and I can tell Postgres that I only need the values for one key. So in that query, you don't even need to use a function with that, which is pretty rad. Like, it's built into Postgres. I can just specify, I want this column, and I want this key from the column, and I want to cast it as text. Note the little operator here. We're going to use this quite a lot for all of our document-oriented data in Postgres. That's our index accessing operator. You'll also see that quite a lot whenever we're getting into the more deeply nested data structures like JSON. Another fun little trick, and this is great because it works for more data types than just Hstore, is there's an Hstore function so that you can query a table and tell Postgres, just give me all of that data back as an Hstore. So it can take a column name and then the value on that field, and then present that to you as an Hstore, which seems kind of like frivolous, but it can be really handy in some contexts. Like if you have any Python folks in the house, the psychopg plugin, for example, has the ability to take an Hstore object and convert it to a dictionary in Python. So if you want to manipulate that data object, I happen to like dictionaries. I use them a lot when I'm in Python. I like Python. This is a nifty little function for that. So similarly, when you're reading, like imagining your Hstore field, you can almost envision it as like a table within a table, really, where I've got a row with information, and then I've got my Hstore field, and I can have 30 keys in there, and I can look at that as almost like a separate nested table. So here, what I'm doing is I'm saying I only need the value of this key and this key from the same column from that table. So I'm getting two different values from one field in a column, or in a table. And I'm going to actually show you this right now, because this is potentially very confusing unless you're seeing it in action. Bless you. Come on. Oop, there we go. Get going. There we go. So reviewing, we still have that XML table, nothing else added. And that doesn't work because I haven't yet created our Hstore extension. But that's a pretty simple matter, so I'm going to do that right now. And now add our table. And how is this to read? Can everybody read the text in the back here? Is that okay? Great. Cool. So here we're again inserting just a straight key value hash that is just text. No problem. And I'm going to add a few more items to make it a little easier to demonstrate, manipulate, or working with multiple data rows. So we've added that. Now if we go on over here, we'll see we've got all our data in. And here, again, I'm demonstrating that typecast comparison. And that works for just so much more than it. You can cast a timestamp with time zone. As you'll note, we do have timestamp data here. This is stored in the database as text, but I could cast that to a timestamp data type if I needed to make that comparison, if I wanted to find databases older than a certain point in time. Hstore lets you do that. So here, we've got 4 records that were bigger than 30 megabytes, and 5 total in our database. So our typecast is letting us make those filtering actions. And now we get a little more fancy, where we're just searching for the resource name, and it is text. So whenever I pull those values out, Postgres presents it to me as text, unless I explicitly alias it. So it's sort of like, it's almost like a view or something. Like I have a virtual kind of column that I'm looking at now. Ooh, yeah, and this is fun. So here, actually, in the slide I was showing the XML. Here, so this is that XML table that I created in the last data type, and you can see I asked for that as an Hstore. So my column name is ID, and the value is 7, and vice versa, and vice versa. So this is a nice little Hstore data object that I could work with in whatever application wants to use that. So if I needed to work with a Python dictionary, even though it's XML, I converted that to Hstore, and I can do what I need with that. And I think we're also going to take a look. Yeah, we are. So here, I'm querying, as previously mentioned, we've got two different keys in one document. And I am querying both of those keys as resource name or as active. So even though I'm pulling things from one field in one row, it has this appearance of looking like a separate table because Hstore lets me treat it that way if I need it to. So that's pretty nifty and straightforward, at least compared to XML. Hi, what's up?
So when you convert the XML to the Hstore, can you query the node separately?
Can I what?
Query the node.
Create a node separately?
Query the node. Can you query the node after you convert to Hstore?
I see what you mean, like the XML node?
Yeah.
No, you can't, because from there, well, I haven't changed the data in place, so the data in the XML table is still XML. So if I wanted to go back and rerun that query with the XPath, I can still do that. Does that help? Great. And unlike XML, you can update with Hstore, which I have done quite frequently, in fact. Remembering, again, that Hstore is just a string under the hood, but with some extra gravy, like being able to add those indexes on a key in your field. It's just text, but that means that whenever you're updating, all you do is you add a concatenation to the value. So I am setting documents equal to documents, concatenating this. Where, and here's my containment operator. So I'm checking where in that string resource name of this value is contained. So I'm filtering. I want to concatenate this string where this string is contained within that field. And you'll note that I am casting it explicitly to Hstore in my query. And that's because this is, like, as I'm typing it in, Postgres does see that as text, so I need to make it explicit. This is Hstore, so you still need to add the extra gravy options to the text. Hey, what's the question?
In this, like, when you are inserting all these fields, there can be some null values with no value at all. Like, in that case, like, if we were running the query with this kind of updates, like if I want to update the value for the previous one and even the record doesn't have. This is similar to the table, right? It's almost like similar to the table, like you will have all the fields available for the record.
I'm not sure I understand the question. Let me reiterate.
In XML,
Uh-huh.
you can miss one column or one value from the total section. So, but here you can define all the values, or you can skip some values where those values will get treated as null.
So the question is, if I want to remove the value entirely, can I treat it as null? I don't think that, no, in the sense that it wouldn't be null because the field still has value. If I wanted to remove the value of this key, for example, I would probably put in an empty string, or I would update it, yeah. You know, that's a good question. Off the top of my head, I would probably put in an empty string, but I would need to double check that for you.
Because if you skip one field, and the data that what it returns is a text field, right? When you write it in straight line, the one field will get missed, and you are querying the data will get correctly displayed, or how it works.
Can you clarify what you mean by miss the field?
See, when you are inserting the data, like some places you don't want to give the information for some of the fields. So that way, like you will be skipping the data for that record. When you are querying, even if this data is written in the database, it will be a text format. When you are querying the data, you will be missing that column when you are searching for the data.
If the key doesn't have a value,
So you're asking what happens if the key doesn't have a value in a given row?
It should be always empty, or that's the question. Like, do we need to mandatory? Is it mandatory or optional? The value.
I see. In that case, what you would probably do, no, you can remove a key, but in that case, what you would do is, again, this is a concat operator, so you can just concat the same value without that. Does that make sense? Okay, and please feel free to revisit that in the question, like at the end. I would love to make sure that we can have a play with this in PSQL and get to the end of that if you'd like.
Because this looks like a text search index. Text search. This is the best option for Google.
The best option for?
In a text field, searching with a big data. This is the best option. Like in Oracle also, we have the text field, big text option. So there you will search the big data with the text option. Text indexes you can create. So the similar thing I'm comparing both between those two.
I see.
Seeing like
I see.
how it works.
Yeah, this is definitely a better option because you can put an index on those keys. So you don't need to do a full text search, which is going to be really expensive. You can index on those keys. So this is updating. And I believe I have a quick demo of how that is going to look. Oh, no. One more quick thing. We return to the containment operator here. So if we wanted to delete an entire record from our Hstore table, we can do that with our containment operator to ensure that this string, this substring, is contained within the Hstore that we'd like to target for deletion. So I'm going to delete the entire row from Hstore samples where the documents column has a value that contains resource name of that specific value. And again, I'm explicitly casting to Hstore because Postgres would read that as text, and it needs to know that we're looking in an Hstore formatted field. So
Characters can be supported here or not in the such string?
what characters?
Wildcard characters, like if you have a space, suppose the user entered something after the field, like you may have prefix or suffix, some white spaces or something there. Can we use wildcard characters here also?
Like if I wanted to say, put a star here?
No, walking slowly after 1, 2, 3, 4.
Yeah.
User immediately after that you have double quotes. Instead of that, if you have some spaces or cap or something, then is that extra characters can get added here, or how the text tree works?
Well, it's a literal. It's like it's a text literal. So if you had extra spaces here, you would It would probably interpret them just as spaces. I would escape them if you're looking for a resource name that specifically has spaces in it. Is that what you're asking? Yeah, cool. So in action, I can show all that. Cool. So this is the query from that previous example where we're just pulling out certain values from that Hstore field. And you'll see some of these resources are set to true, is active. They are true. These databases are active in my cluster in my staging environment. I just yoinked some data from my staging environment. So if I want to update some of these to be no longer active, I'm retiring these databases from my cluster. But I only want to do it for specific names. So I'm checking where the string swimming swiftly, et cetera, is contained. So I've just set those to false. And now when I redo my query, you can see that that update has been updated. But again, looking at this query, we haven't touched anything except that documents field. We've only touched one field in one table. So it's effectively as if we had, it was just a document blob. You don't need to worry about any other tables. It's just all data contained in one field. Similarly, if I wanted to delete some records, I'm using that containment operator to delete the entire record. So I've got one record gone. So I think now I have 4 items in this database. And that is Hstore. Which now brings us to the really exciting data format. This one's my favorite. Now we're going to take a look at JSON and JSONB. And also, if you're going to be around in the evening, Peter Van Hardenberg is also going to be touching on JSONB a little bit in his overview of all document types in Postgres. Or data types in Postgres. I'm focusing on the document data types, and he's doing an overview of all of them, so he'll also touch on this. I'm going to present JSON and JSONB together, since syntactically they're really very similar. Under the hood, JSON is just like text, much like Hstore is text. However, JSONB, the B stands for better. It's better JSON. But it also happens to be a binary data object under the hood. So you got faster reads. It really is a better data type. But since functionally, like the way you access that data feels very similar, I'm going to go over both of these data types together. And that'll allow me to highlight some of the fiddly differences between the two data types as you're interacting with JSON. Before we get really digging into it, I wanted to give a quick overview of the operators that we will use with JSON. And some of these are going to look familiar, like that handy little index operator that we've been using for Hstore. So this just gives you, key, value. But the magic of JSONB is that you can get really richly nested data types. You don't need to stop at just a key and a value. The sky's the limit here. So as we get a little more complex, we're going to use this operator in a really similar way. As we traverse down our JSON object, we can use that. Similar looking, but functionally very different, is our getJSON object by text field. And this one will make a little more sense as we go into the concrete examples, but this is how you would match how you would match child objects by text if you don't happen to know the index value for those objects. Similarly, we are using the containment operator again. And a new operator that we haven't really looked at until now is the question mark one, which is handy, where you can check for the existence of a key in your JSON object. So let us take a look. So I'll set up my table. I'm going to add a text JSON column and a binary JSON column all in the same table. So again, we can compare those two data types and how they behave. And it's pretty straightforward, formatted as JSON, formatted as JSONB. This all works out of the box with Postgres, so you don't need to create any extensions or install any modules or anything like that. It just works. Just works, TM. So one of the big differences with, actually, so one of the questions someone might have is if you have JSON-B and text JSON, why would you bother with the text JSON, right? Like I'm talking up the JSON-B, it's pretty great, it's fast reading, and that's all true. JSON-B is rad. Some examples that you might want to use text JSON with are really if you, again, have some legacy code that can't really handle the binary object. Like, for the most part, you can use JSON-B. There are very few cases where you won't use text JSON. So the big thing that formatting your field as text JSON that it gives you is it will check to make sure it's well-formed JSON. That's kind of the big win that you're getting with the text JSON field. But you're definitely getting way more bang for your buck with the JSON-B. So here you'll see I'm inserting into this into this text JSON column a little bit of JSON, and it's well-formed JSON, so it will accept this. Just a little note, this is data from one of the Google Fit APIs. This is some data from a side project I did a couple of years ago with Heart8 data. And I'm putting this in the text JSON field, or I will whenever we get to the live demo part of this. And again, now JSON, getting really exciting with how you can read it. So also, I would encourage you to check out the documentation for the JSON object specifically, because there are a ton of functions that you can do with that JSON data, more than I really have time for one talk. So there's a big toolkit available to you there. Definitely check that out. One of those is the JSON object keys function, where I don't know how often, like whenever I'm navigating a new database, I'm always frequently checking, okay, like how many columns do I have here? What am I working with before I craft my query? And the object keys function lets you do that with your JSON document. It lets you say, hey, what keys do I have here? Where can I drill down into this document? What's available to me? And this function gives you that. This isn't actually SQL right here. This is just for quick reference. This is what this is a path, a well-formed JSON path conforming to the JSON standard, sort of like the XPath. This is how you would traverse a JSON object with these little brackets. So we have a key, and we have an index array indicator, a key, et cetera. And so that's how I would traverse down a JSON document. So if I wanted to translate this to a SQL query, I would use that arrow operator. Again, much like we did with the Hstore document, where you have key value. It's the same thing, just with other layers on top. So here we have our column, and then we have our key, and our index point, and another key, and another index point, and then the actual value that we want, which is pretty far in there. But this is, I think this is really exciting because this is a pretty complicated document, and I can still drill right down in there and get exactly the data that I need. Am I blocking your view of the slides? You OK? OK. Similarly, so here I'm going to start getting into the difference between text and JSON-B. So here we have that little question mark operator that lets me check, is this key present in the document? And that operator doesn't work with the text JSON field. So I do need to add a typecast to JSON-B in order to use that operator. But if I am querying from the binary JSON column, I don't need to worry about any typecasts. That operator will already work with JSON-B. Similarly, we can, again, remembering the difference between the arrows, this is our getting the object as text. So here I'm strictly comparing text between these things. So let's say I only want a JSON record where the binary JSON has text, min start time matching this. This is epoch time to nanosecond precision, because that's kind of important when you've got like a lot of data points, I guess. So let's dig into this. This is one of the more fun ones. Boom. So reviewing what tables we've got our Hstore and our XML. So I'm going to go on ahead and add our JSON table. And we've got a column for binary and text JSON. So to start out, I'm going to add a teeny bit of information in that text JSON field, not the full-on complicated JSON document, just a little. And you'll see that inserts. That's valid JSON, so the text JSON column accepts that. Now, this is the full-on JSON response from that fit API that I pulled the text from. So here's a teeny little bit. That's the stuff we just inserted. But then this is the whole full-on document. And you might recall from our index path, we've got a key, and then we've got an index, or we've got an array that you can index 0.1, and then you've got your key, and you can drill pretty down deep in there. So I'm going to insert a few of these records just on the background. We've got one is text and one is binary JSON. Cool. So now we're going to select those keys. We're going to just get a look at what we have to work with. So recalling that document, here are our top-level keys, the start, end time, the data set, the data source. Catalog is there. Just for experimentation's sake, I converted that XML book document to JSON to see what would happen, and that worked out a little bit. It didn't turn out to be an easy thing to query. That was not a good use case for this document type, though. But I can see that, using that function, I can see, okay, these are all the things that I have to work with. But because I want to have a look at that, the health data, now that I know that that top-level key is there, I can start drilling down. So here's our column, and then index of the top-level key, the array point, and I can drill right down just to that one value. So you'll recall that big, complicated JSON blob. I can drill right down and get straight to that, which is pretty powerful, especially like if I need to store this, like again, this is a data set, right? This is a heart rate data set. If I'm using a health app, for example, and I need to retain that information, if I want to pull that in and have it available to manipulate in memory, this is pretty powerful stuff. Now, again, remembering this is binary JSON, so this doesn't pretty print. This is just a blob. There we go. Yeah, so again, pulling from the text, we're only going to pull out a record where that key is present, but because it's text, this does pretty print. So, if you're querying things live, that's a thing to keep in mind. There are ways around that. There's a function to pretty print with JSONB that I'll go into a little bit in the end. There's an interesting gotcha on this slide there. And I think that might be about it. No. Now we're also matching, yeah, because so let's say we need to get data for a particular point in time. Again, this is epoch time, but this allows me using that string matching. So not the index traversal, but string matching, since that arrow with the 2 carets lets me match on text. So I can use that to say I only want to look for data that matches my certain timestamp. I want something after my timestamp. Which is really quite powerful, because if this data scales, like I could have years of data, for example, and that would give me the availability to quickly and powerfully get the data I need by time, even though it's deeply buried in that JSON object. So here, exactly, now I'm finding my data point. It's a similar data point from before, but I can find it by timestamp, which is pretty cool.
Can you index this JSON?
You can. You can. You can also update it, unlike the XML. And there are a couple ways that you can update this also. So with the Hstore, it was a straight up rewriting the key value. Here, there are a couple ways you can do that. You can concatenate, which is what I'm demonstrating right here. It's just a straight up concatenation for everything under this top level key. So just rewriting everything. Oh. Clickers not working? Why are you not working? There you go. So that's if you're concatenating the top level key. Conversely, I mean, maybe you don't want to overwrite everything underneath that top level key, because that's a lot of data to overwrite. If that's the case, if you want to get really focused and precise with what you're updating in a JSON object, you can use this JSON B set function, and that lets you drill down pretty specifically. So it takes a few parameters, this function. The first parameter is which column you're updating. The second is the path, the JSON path that you'd like to update as text. So our top level key is address, and then the secondary key is street address. And then the final parameter is what you want the update to be. So let's say it's on Test Street, and I want to update it to Lorem Ipsum Street, and I can do that. And again, I'm using an explicit typecast to JSON B, since this will look like text whenever I'm adding the query. I would like to select this, use the function for the table JSON samples, and then I'd only like to make this update where I have the text matching for the last name. So where the last name matches Gilmore, my last name, because we don't want to update any information for the wrong people. That would be awkward. So let us take a look at that in action. And as you can see, what I'm going to do real quick is insert some, where'd my cursor go? There it is. So here, I'm about to insert some test data that looks like an address to make it easier for us to work with. I'm going to insert it into our JSON B column. And then I'm going to show you some functions to make that a little more readable. So we're inserting into JSON samples in the binary JSON column this data. I'm using the street address for the conference center here and some fake phone numbers. So now I've got my data to work with, and I can select stuff. It's binary JSON, so it looks a little messy. Let me turn on the auto display. A little bit easier, but still suboptimal to read. Oh, thank you. Oh, yeah. How do y'all like that? Good? Cool. So here, yeah, OK, great. So we're taking a look at our table schema. Again, we have binary JSON and text JSON. And I put it in the binary JSON, which means that whenever we read it, it's that awkward, blobby, not fun to look at result. Now, I believe what I do next is I query it. Yeah, here we go. So this is exciting. This is the JSON B pretty function, which lets us take a look at that binary JSON text, or binary JSON result as text. So that way you get the nice formatting as a JSON object. Really great, yeah. So even though you're getting the performance benefits of this column, I can now read it, and it's very human-friendly now. So let's go on ahead and update some stuff. Cool. So here, the first update we're doing is that straightforward concatenation, where we're just updating everything underneath that top level key here. So I'm updating it to Test Street in Oakland. So I don't live here, I live in Oakland. So let's update it to reflect that. And now I'm in Oakland. And I've pretty printed that so you can see it. It's pretty great. But that's not really what's exciting with JSON, right? Like if you only cared about concatenating for top-level keys, you could use Hstore, right? So the powerful thing with JSON is being able to update and really drill down into that object. So that's what we're going to do here with that JSON B set function. And here, I'm only updating the street address to Lorem Ipsum Street. Like right now, it's Test Street. We're going to make it Lorem Ipsum Street. And here it is. Our update worked. We've got Lorem Ipsum Street. And this is actually really interesting. So now I'm going to try and use the JSON B pretty function, and it's cached. It still has Test Street from before, which is a nice thing to keep in mind, a little bit of a gotcha. So that function will cache things and trip you up. But anyway, so this is a pretty good overview of the JSON B stuff, but there is really a lot more. Like there's a whole long page in the Postgres documentation of other functions and tools with this JSON B data type that you can use, which I encourage you to check out. So a quick recap, because we went over a lot, some of the pros and cons of each of these data types. Like XML is nice. Like using XPath felt very intuitive to me. Everybody's going to have different preferences, but like XPath is pretty nice and straightforward, but you can't update it, which is kind of cruddy. Similarly, you can't index with the XPath. You can index with these items right here, but with Hstore and JSON, those are both text, so they're not going to be quite as performant as your JSON-B. Although with the text JSON, you still can do the richly nested data structures. But really, your hot ticket is going to be the JSON-B because it's deeply nested data. You've got your nice, fast reads. You've got all your indexes that you can do with JSON-B. You're going to have some higher cost writes, but that's always going to happen whenever you have that index anyway. So you really can't lose with JSON-B, I think. Why is my clicker not working? Oh. So here is a quick rundown of some of the links that I've pulled test data from and references to the Postgres documentation where all these functions are. That's a lot to copy. So if you want to scan that QR code, that takes you to my GitHub page. Certainly. There you go. So this is the text, just the text link. And then if you scan that QR code, that'll take you to my GitHub page that also has all those links in the README. So the SQL is in my GitHub. You can just copy that. And then the links to all of the Postgres documentation is also there. Good? Cool. There you go. That's the QR code. I'll leave that up for a minute. My GitHub handle is mandagill, so you can find it there too. And I love that y'all have been good about jumping in on questions. I'm kind of curious if anybody has any more questions. Yeah?
The JSON pretty caching, is that within the session, or is that?
Probably. What do you mean by the session?
Well, I mean, within your connection, where is that cached?
Oh, yeah. Oh, yeah. Probably, Greg, you got any input on that? Probably resetting the connection would definitely do it, because I found it fixing that, but I'm wondering if there are other ways of busting that cache. You have any? Yeah?
Which session are we talking about? I'm sorry.
That's
how do
fine.
you get around the JSON pretty caching if you know that you're updating?
Yeah, the JSON-B pretty printing.
Invalidate the cache.
Yeah. Oh dear.
Yeah, I think it's probably session local.
Cool.
But yeah.
That's interesting, because I was p-SQL'd into a Postgres database, so I wasn't accessing a local database. But when I reset the connection, that fixed it. So yeah, I've totally messed up my slides. It's all right. We can keep looking at that. Any other questions? I think I saw a hand over here. Yeah.
How does the update works with the list inside JSON? Can you navigate only by item?
Sorry. How does the update work with what?
Lists inside
Lists in JSON.
Yeah, I'm navigating by item index, so can you navigate by additional items?
I see. Oh, that's an interesting question. I'm not sure you can do that because the function I showed is a text matching. But let's take a look at the docs, because it's probable that there's another function that'll help you there. This is actually really hard to do. There we go. Yeah, so here are the operators that we went over. And then here are some additional operators. So if we're looking to update by index, let's see. This is probably your hot ticket out of a text array. Does that help?
No, by index is fine, but often you don't know the index number.
It's true.
Right? So you need to have some kind of conditional search.
Okay.
Most of the data stores like Mongo actually allow them to do that. I'm not sure.
I see. Oh, yeah. In that case, then your strategy might better be using Mongo in addition to your Postgres cluster, since there are foreign data wrapper repos available for that. So that could also be an option for you. Any other questions? Go for it.
Is there a functionality to do aggregated functions on the JSON elements now?
What function?
Is there a functionality to do aggregated functions like group by the elements of the sub-elements on the JSON? Means if I want to just know the count of all my sub-keys, is that the whole table?
Oh, interesting. I'm not sure about that. However, you can count the length of your array. So like, for example, whenever we're looking at XPath and it returns all of those items as an array, you can count the length of the array, which would probably achieve the same goal.
You mean on the client after retrieval everything?
Yeah.
Oh, no.
Okay. I see. I see. I think I saw a hand over here. Yeah?
Yeah, I was, hold on, let me.
Sure.
I'll actually interrupt in a minute. I'll put my hand up in a minute again when I actually find the link, because there's some extra JSON functions that Andrew Dunstan wrote that are available on PGXN that
Cool.
do additional aggregation things, et cetera.
Cool. PGXN? Let me make a note of that. That's cool. Notes. Great. New note, PGXN. Great. And were there any other questions? Yeah.
Execution plan for this JSON objects, like, is that a normal way we can use the execution plan and see how things works?
Sorry?
The execution plan, how it works with the regular tables, joining the condition, everything like the same, like how you query it and how you execute the plan is the same. Can we use the execution planner for this also? The JSON tables?
So I'm understanding the question properly. So you're querying within one document and you'd like to use the execution planner for that?
No, execution planner, how it works for the regular query is the same thing over here also, or are there any differences?
Not that I'm aware of, no. Thank you.
I mean, explain, analyze will work. So.
Yeah. Let's see. Do I have time for one more question? All right. I have time for one more question. No? No? Hey, yeah, at the back.
Yeah, do you have any performance comparison with other JSON function like mobility or?
Like overall querying? Yeah. Oh, I mean, sorry?
He's asking about performance comparison with Mongo and this.
Oh, yeah. I mean, I couldn't really make a statement along those lines unless I had two queries that could be reasonably and empirically compared. Like, I've designed some queries specifically to showcase functionality in Postgres, but I would need to design a query in Mongo and compare that. So the short answer is it's kind of an apples and oranges question, and I'd need to do a little more research to make sure I've designed an empirically valid test to make that work. That's probably a disappointing answer. Does that help, though? Okay. Thank you so much for listening, and thanks for all your really good, engaging questions. I appreciate it.